Welcome to M&E. We have a square-shaped quadrilateral, and from here we are to calculate the blue area, that is the area of this quadrilateral here. We have the length of this side to be 10 meters. The size of this angle is 15 degrees. This line and this line are parallel. So how can we solve this? How can we calculate the area of this quadrilateral? We can see it has the shape of a trapezium. We start with this square here. A square is a type of quadrilateral which has all four of its sides to be equal in length. That is, this side, this, and this are equal in length. So since this side is 10 meters, this side, this, and this must also be 10 meters in length. Another property of a square is that all four of its angles are right angles. That is, this angle, this, and this are right angles. Look at this triangle here. Because of this right angle, it is a right angle triangle. Since we have the length of this side to be 10 meters and this angle to be 15 degrees, we can use a SOHCAHTOA to find the length of this side. Taking this angle as theta, there is the opposite, say x, and there is the adjacent. From here, tan theta equal to opposite over adjacent. Theta is 15 degrees, opposite is x, and adjacent is 10 meters. So tan 15 degrees equal to x over 10. Multiply both sides by 10. Here 10 cancels 10, while here tan 15 degrees times 10 is 10 tan 15 degrees. So 10 tan 15 degrees equal to x. That is, x equal to 10 tan 15 degrees. The tan ratio of 15 degrees is 2 minus root 3. So x equal to 10 open bracket 2 minus root 3. That is, the length of this side is 10 open bracket 2 minus root 3 meters. Recall, the whole length of line AB is 10 meters. So since this is 10 open bracket 2 minus root 3 meters, this must be 10 meters minus 10 open bracket 2 minus root 3 meters. We can see 10 meters is common, so we factor it out. It is now 10 meters open bracket 1 minus bracket 2 minus root 3. Minus into bracket 2 minus root 3 is minus 2 minus root 3. Minus root 3 is plus root 3. 1 minus 2 is minus 1. Minus 1 plus root 3 is root 3 minus 1. So it is 10 meters open bracket root 3 minus 1. Come to this triangle BCD. It is a right angle triangle, and we have this side and this side to be equal in length. That is, it is an isosceles right angle triangle. The angles of an isosceles right angle triangle are 90 degrees, 45 degrees, and 45 degrees. So since this angle is 90 degrees, this and this must be 45 degrees. Recall, this whole angle ADC is a right angle. So since this is 45 degrees, this must be 90 degrees minus 45 degrees, which is 45 degrees. The same is here. Since this is 45 degrees, this must be 90 degrees minus 45 degrees, which is 45 degrees. Now if you haven't forgotten, this line and this line are parallel. So since this line makes an angle 45 degrees with this side, the angle this line makes with the line must also be 45 degrees. So this angle is 45 degrees. And similarly, since this angle is 45 degrees, this must also be 45 degrees. Now look at this triangle. It is a right angle triangle, and we have this angle and this angle to be congruent. That makes the triangle an isosceles right angle triangle. The perpendicular sides of an isosceles right angle triangle we know are congruent. That is this and this. So since this is 10 meters open bracket root 3 minus 1, this must also be 10 meters open bracket root 3 minus 1. Still on the triangle, we can use the Pythagorean theorem to find the length of this side. It is the hypotenuse, let's say y. The Pythagorean theorem states that the square of the length of the hypotenuse of a right angle triangle is equal to the sum of the squares of the length of the two other sides. So if we apply the Pythagorean theorem here, the square of this y must be equal to the sum of the squares of this 10 meters open bracket root 3 minus 1 and this 10 meters open bracket root 3 minus 1. So y squared equal to 10 open bracket root 3 minus 1 all squared plus 10 open bracket root 3 minus 1 all squared. If you look here, 10 into bracket root 3 minus 1 is common. Factor it out, it will be 10 open bracket root 3 minus 1 all squared into bracket 1 plus 1. 1 plus 1 is 2. 10 into root 3 minus 1 all squared into bracket 2 is 2 times 10 into bracket root 3 minus 1 all squared. Now from y squared equal to 2 times 10 into bracket root 3 minus 1 all squared, we take the square root of both sides. Here square root of y squared is y, while here square root of 2 times 10 into bracket root 3 minus 1 all squared is root 2 times square root of 10 into bracket root 3 minus 1 all squared. This square root cancels this square. Root 2 times 10 into bracket root 3 minus 1 is 10 root 2 into bracket root 3 minus 1. So y equal to 10 root 2 into bracket root 3 minus 1. That is, the length of this side is 10 root 2 into bracket root 3 minus 1 meters. Now let's focus on this line AD. Its length is 10 meters, but we have this to be 10 meters open bracket root 3 minus 1. This segment will be 10 meters minus 10 meters into bracket root 3 minus 1. Factor out 10 meters. It is 10 meters open bracket 1 minus root 3 plus 1. 1 plus 1 is 2. So it is 10 meters open bracket 2 minus root 3, which is 10 open bracket 2 minus root 3 meters. Look at this triangle now. On this triangle, both are right angle triangles. This side and this side are equal in length, and similarly this side has its length to be 10 open bracket 2 minus root 3 meters, and this side also has the same length. That fulfills one of the criteria for the congruency of two triangles, which is SAS, that is two pairs of equal sides and the angle between them be congruent, which is this right angle and this. Now congruent triangles have all their corresponding sides to be equal in length, and also their corresponding angles must be congruent. So this side and this side are equal, and this angle and this are congruent. So since this is 15 degrees, this must also be 15 degrees. Now from this triangle, you know, since this side and this side are equal, this angle and this must be congruent. Assume their sizes to be A each. If we let this be C, based on the rule that the summation of angles in a triangle is 180 degrees, A plus C equal to 180. A plus A is 2A. Take C to the right. So 2A equal to 180 minus C. Now if you look at this whole angle BCD, it is a right angle, but we have this to be 15 degrees, and this is also 15 degrees. Therefore, this C will be 9 degrees minus 15 degrees minus 15 degrees. Minus 15 degrees minus 15 degrees is minus 30 degrees. 90 degrees minus 30 degrees is 60 degrees. So C equal to 60 degrees. That is, this angle is 60 degrees. Substitute the value of C here. Now 2A equal to 180 degrees minus 60 degrees. 180 degrees minus 60 degrees is 120. From 2A equal to 120, A equal to 120 divided by 2, which is 60 degrees. So A equal to 60 degrees. That is, this angle and this angle are 60 degrees each. The fact that all the angles of a triangle are 60 degrees tells us that it is an equilateral triangle. But before that, we know this line is parallel with this. So since this angle make an angle 60 degrees with this line, this angle must also be 60 degrees. And similarly, since this is 60 degrees, this will also be 60 degrees. If you look at this angle and this angle, they are lying on the same straight line. I believe we all know that the angle on the straight line is 180 degrees. So since this is 60 degrees, this must be 180 degrees minus 60 degrees. 180 minus 60 degrees is 120. Now look at this triangle. Since we have the size of all the angles and the length of this side, we can use the sine rule to find the length of this side. Let's say Z. By the sine rule, we know that this Z divided by the sine ratio of this angle 45 degrees must be equal to this 10 meters divided by the sine ratio of this angle 120 degrees. So Z over sine 45 degrees equal to 10 over sine 120 degrees. Sine 45 degrees is root 2 over 2, which is 1 over 2 root 2. And sine 120 degrees is sine 60 degrees, which is root 3 over 2. And root 3 over 2 is 1 over 2 root 3. So Z over 1 over 2 root 2 equal to 10 over 1 over 2 root 3. Multiply both sides by 1 over 2 root 2. Here 1 over 2 root 2 cancels 1 over 2 root 2. While here this 1 over 2 cancels this 1 over 2. 10 over root 3 times root 2 is 10 root 2 over root 3. Multiply by root 3 over root 3. Root 3 times root 3 is 3. And root 2 times root 3 is root 2 times 3, which is root 6. 10 root 6 over 3 is 1 over 3 open bracket 10 root 6. So Z equal to 1 over 3 open bracket 10 root 6. That is, the length of this side is 1 over 3 open bracket 10 root 6 meters. Now let's look at this big equilateral triangle. The formula for calculating the area of an equilateral triangle is 1 over 4 root 3a squared, where a is the length of one of its sides. The length of this side is 10 root 2 open bracket root 3 minus 1. So a equal to 10 root 2 open bracket root 3 minus 1. Substitute here. Now area of big triangle equal to 1 over 4 root 3 open bracket 10 root 2 into bracket root 3 minus 1 all squared. 10 root 2 open bracket root 3 minus 1 all squared is 10 squared times root 2 squared times root 3 minus 1 all squared. 10 squared is 100. Root 2 squared is 2. 100 times 2 is 200. Root 3 minus 1 all squared is root 3 minus 1 times root 3 minus 1, which is root 3 times root 3 minus 1 minus 1 times root 3 minus 1. Root 3 times root 3 minus 1 is 3 minus root 3. Minus 1 times root 3 minus 1 is minus root 3 plus 1. Minus root 3 minus root 3 is minus 2 root 3. So it is 3 minus 2 root 3 plus 1. This 3 plus this 1 is 4. So it is 4 minus 2 root 3. This 1 over 4 times this 200 is 50. 50 times root 3 is 50 root 3. So area of big triangle equal to 50 root 3 into 4 minus 2 root 3 meter squared. Keep it aside. bring back our formula for calculating the area of an equilateral triangle, 1 over 4 root 3a squared. Look at this small triangle. It is also an equilateral triangle. The length of this side is 1 over 3 open bracket 10 root 6. So a equal to 1 over 3 into bracket 10 root 6. Substitute here. Now area of small triangle equal to 1 over 4 root 3 into bracket 1 over 3 open bracket 10 root 6 all squared. 1 over 3 into bracket 10 root 6 all squared is 1 over 3 squared times 10 squared times root 3 squared. 1 over 3 squared is 1 over 9. 10 squared is 100. Root 6 squared is 6. 100 times 6 is 600. 1 over 9 times 600 is 600 over 9. 9 is 3 times 3. This 600 divided by this 3 is 200. So it is 200 over 3. Therefore, area of small triangle equal to 1 over 4 root 3 into bracket 200 over 3 meters squared. This 1 over 4 times this 200 is 50. From this triangle, if we subtract the area of this small equilateral triangle, we'll be left with the area of this trapezium, which is the blue area we are asked to calculate. So blue area equal to area of big triangle minus area of small triangle. We have their values here, so we substitute them into this equation. Now blue area equal to 50 root 3 into 4 minus 2 root 3 minus root 3 open bracket 50 over 3. Root 3 into bracket 50 over 3 is 50 root 3 over 3. Now from 50 root 3 into bracket 4 minus 2 root 3 minus 50 root 3 over 3. 50 root 3 is common. We factor it out. So it is 50 root 3 open bracket 4 minus 2 root 3 minus 1 over 3. 4 minus 2 root 3 minus 1 over 3, simplifying into a single fraction, is 4 times 3 minus 2 root 3 times 3 minus 1 all over 3. 4 times 3 is 12. Minus 2 root 3 times 3 is minus 6 root 3. This 12 minus this one is 11. So it is 11 minus 6 root 3 all over 3. Therefore, blue area equal to 50 root 3 open bracket 11 minus 6 root 3 all over 3 meters squared. Thank you for watching. Please subscribe, like, share and comment, and also turn on notifications. Thank you.